in Blender, and you can do so many amazing things. I'm really happy to live in the 21st century because Blender community is so supportive. If you just release anything interesting, they will gladly help you to distribute it and to spread the word and even to support you financially. And this project, this video course, it is our most successful project up to date. It's kind of a bestseller on Blender Market, on Gumroad, and it completely changed our lives. It gave an unexpected spin to our careers and stuff like that. As I've said, we've been working on it with Aidy Burrows for a solid 6 months. Aidy was in Manchester, I was in Brest in Belarus, and we haven't seen each other, while we've been working on it, and it's pretty fun. And one of the reasons why I want to talk specifically about Space VFX is because I don't understand myself. How did we manage to pull it off? Because it was a huge project. The initial idea was just one screenshot that Aidy sent to me. Like out of the blue, he sent to me the screenshot and he asked, "Hey Gleb, how about recording a video course about creating the galaxy in Blender?" And I was like, "Galaxy?" He said, "Yes, galaxy, planets, asteroids, nebula, what else? Black holes." I asked, "All right, and what do you want to do actually? Just give me some guidelines." And he said, "Imagine this, black holes, wormholes, warp drive effects from Star Trek, a total kind of video course, the ultimate guide to creating the galaxy in Blender for nerds." And I said, count me in, because this was an exciting idea, you know. And if only I knew that it would turn out to be a 20+ hours video course, I would probably took this opportunity because it was a hell of a fun to work on it. And the first thing we did is, is pre-production. Because it's fun, because you can play like kids in a sandbox with your ideas. We created this brain dump, as we called it, on Trello. Trello is an online resource for teamwork and collaboration. So we created this page on Trello and started to populate it with our crazy ideas. We wanted this, we wanted that, like planets, asteroids, procedural spiral galaxies, nebula, and then it started to expand like the universe itself. You know, because we got quasars, wormholes, polar lights, exploding planets, space dust and debris, neutron stars, and crazy stuff like bioluminescent planets with alien life in it. It was crazy. It kept expanding like forever. And we, out of the sudden, find out that we have already spent 1.5 months in pre-production. And we haven't even scratched the surface of the video course. Like, what the heck? Like, we've been working for 1.5 months, and we haven't even scratched the surface. We used it as an excuse to rewatch our favorite Hollywood movies, Aliens, Predators, Aliens versus Predator, Star Trek, Star Wars, Battlestar Galactica, Avatar, Interstellar, and stuff like that. Our reference folder looked really bloated, and we felt like we are losing control over the process. So, and on top of that, we have been running into all kinds of issues with Blender, with cycles, with our own lack of knowledge. Because we've been used to see this error. You get this error when you run out of memory on your video card, and obviously such massive, supermassive stuff like planets, nebula, asteroid fields, they require some extraordinary power to render it out, or extraordinary hacks, some crazy game development techniques to get around the lack of memory and stuff like that. We hit the brick wall of long computation time, because my natural instinct when I need something like asteroid field is just, well, populate the whole scene with asteroids, like create billion particles, stuff like that. And when you need, say, fog, you just create volume scatter and volume absorption and hope that it will be alright. But if you just brute force all these techniques, if you just populate your scene with stuff, it doesn't work out of the box, because maybe universe is infinite, but the computing power is definitely not infinite. The second problem was texture resolution. Initially, we wanted to use image textures, like let's download planet surface maps from NASA, stuff like that, high resolution stuff. But it's nearly impossible to find really high resolution texture maps, and especially considering the fact that we needed these textures to be free, to be in public domain, so we can bundle it with the course so other people can follow along. And no matter how high is the resolution of the texture, like even if you have 64K texture, still you zoom in really closely, you see this blurry mess. It doesn't really work. You need to have some kind of system with levels of detail. The other problem was the lack of time. We wanted to include something like lens flares, because every movie nowadays feature some kind of lens flares. If you see the shot with the planets, inevitably you will see some kind of lens flare. We wanted to bundle it with the course, an add-on or something like that. Aidy started to work on the prototype, and it looked kind of nice, but we realized that we don't have enough time to really polish it, to make it production ready. So we abandoned this idea. We also wanted to include complex simulations, like exploding planets, because it's fun. And just imagine this. It would create such a nice chemistry between tutorials. Like, first, Aidy explains how to create a planet, and in the next chapter, I explain how to shatter it to pieces. That would be nice. That would be nice narrative, a nice chemistry between tutorials. And if you try it, simulating smoke in Blender, you know that it works kind of nice for the puffs of smoke, for the small-scale simulations. But if you want to go really complex and to scale it up to some crazy dimensions, you run into all kinds of issues, like very quickly. And the first issue and the hardest thing to overcome was our own lack of knowledge, you know. And we didn't want to spend too much time on such features. And very complex simulations was even harder, right? When I saw this fully volumetric nebula by Tian van der Zalm on ArtStation, I immediately shoot a message to Tian. I asked, how the heck did you do that? And he replied to me that he used smoke simulation, and then he just used like 2-3 billion particles on top of it with some turbulence field to distort it and stuff like that. I thought, nice, I will replicate it in Blender. Should be easy. I tried, I failed miserably. And maybe everything else was our fault, but this is the fault of Blender, I claim. Alright, so we had to embrace the limits. First, we wanted to do so many things, like exploding planets, like crazy lens flare effects, and it was our object of desire. We just really badly wanted to do it all. But then we had to go through this disillusionment to realize our own brokenness and vulnerability and concentrate on things that we can do. And the solution was to kiss. So the solution was to keep it stupid simple. That means if you cannot prototype a feature in 1 or 2 days, like throw it into the trash bin, because you won't have time to do it properly when you have to make video course, which is 20+ hours long and so on. And we started to cut features that we really wanted to include first, but we decided let's just cut it out. So we said goodbye to big image textures, we said goodbye to complex simulations, to real volume shaders for the most part, to spiral galaxies because it looked like macaroni monster, all these nodes. And we said goodbye to complex math and physics, like this gravitational lensing effects around the black hole. We just said goodbye to all of that and decided to cheat like an artist instead. That means to be resourceful and to be brave about cutting features and concentrating on what you can actually do. Imagine like 2 circles, 2 intersecting circles. The first one is things that you can do, and the second one is the things that like would be so nice to include in the course. And in the intersecting part of that circles, you should probably aim for these parts to do things. And just to give you a glimpse of our thought process, which went into creation of this video course, for the planets, we decided to split the task in two parts. For the simple planets, say for the planets when you don't need to have a close-up shot, we just used image textures, because when you just see planet from a distance, you can get away with using textures, like image textures from NASA, from Celestia, Mother Lode. These are nice resources to get textures, by the way, which are free to use, which are public domain. And this is a rectangular texture. This is kind of a texture that is meant to be used with spherical projection to kind of texture spherical objects like planets. And you plug it into the image texture node, and you use sphere as a projection type over there. And later on, you can, for example, if you need infinite varieties of planets, you can do this. You can take equirectangular texture of Moon, mix it with the equirectangular texture of Mars, using the texture of Io, one of Jupiter's moons, as a mask. Or you can take Earth, mix it with Venus, using Jupiter as a mask. And this way you just quickly get infinite varieties of different planets, which I think look very nice. And for the advanced planets, where we needed kind of close-up shots, we used slightly different technique. We took a bunch of aerial shots, the bird's eye view shots from Pixabay, and then I created something that looked to me like a planet surface map. And we made it seamless, so when you repeat the texture a few times, you don't see the seam, right? And it looked okay, but again, if you zoom in really closely, you see the blurry mess of pixels. And you just have to kind of work around the issue. And what you can do, you can just tile the texture, right? Repeat the texture a few times. But it looked not very nice. But it looked nice when you zoom in. But actually what you see here is this. So what you can do, and Aidy came up with a very elegant solution inspired by game development techniques, because Aidy had a game development background, and he's a real wizard when it comes to optimizations, to some crazy hacks. So we used the distance from the camera to the object, this node, to smoothly blend from one texture to other texture, which is tiling lots, which is repeating. So when you zoom in, the second texture gets revealed, and that is your level of detail system. So you can go from your original texture to some other very detailed bump map or things like that. That was our solution for zooming in to the planet, and it works really well for the close-up shots, and it don't require you to have very high resolution image texture, stuff like that. And for the atmospheric effects, we just created some kind of, imagine onion, like a few layers of stuff. The first layer was clouds, just a simple transparent texture. The second layer was also clouds with a little bit of diffusion going on, with a little bit smoother texture. And for the Rayleigh scattering effect, this effect, then the sun rays hit planet atmosphere and get diffusion is going on. Scattering of light. We just use a simple emissive shader with the normal node to control the fall-off effect. So nothing special. You can see that this is just an onion, something like that. It creates this depth. It creates the parallax effect. So a few hacks produce really physically plausible effect. I'm slightly suspicious of the term physically correct. I like to use physically plausible. If it looks right, it's probably okay to use it. And surprisingly, it worked also for extreme close-up shots like this. And it really looks like the light rays, at least for me, like the light rays are scattered in the atmosphere and things like that. And on top of that, you can use just simple things like procedural noise texture in Blender. You can animate its coordinates to make it kind of shift position. And using just simple noise, you can create a bunch of things like sun. If you combine it with atmosphere of some kind, like I described. And asteroids. One more thing where we apply this keep it simple principle, like how to model 10 or 20 asteroids very quickly. You can do it by hand. It will probably take some time, quite a bit of time actually, if you're gonna sculpt it. So other way of doing it is using modifiers. So you just use displacement modifier and procedural noise, like Voronoi noise that you see here. And you plug Voronoi noise into procedural modifier, and this 2D texture, this or rather 3D texture, displaces your original geometry. And then you stack a bunch of noises one on top of the other, like Musgrave noise, some other noises, and you quickly get something that looks like asteroid, actually. And the great thing about 3D noises is that they are 3D. That means that if you have this stack of modifiers, of displacement modifiers, with noises, and then you move your object in the viewport, you get into some other area of noise, and it shapes the object differently, and you quickly get, again, infinite variations of the original asteroid. And this way we were able to quickly generate an insane amount of different stuff. And for the gas giants, my first attempt was to use real volume shaders. And I think it looks promising, but again, it kind of looks rubbish at the same time. So I decided to abandon this and just use simple things, use procedural noise. And surprisingly, procedural noise in this case looks like real shots from a Juno drone, which NASA posts on Twitter and stuff like that. And this is not real particles, this is just, again, texture, obviously. For the nebula, this is smoke simulation. I haven't shown it to anybody because I think it looks nice, actually. This looks nice, this also. But for the puffs of smoke, it looks really awesome. But for nebula, for the massive object, it doesn't work anymore. If you crank up the voxel grid resolution, you end up with having massive cache files, and we kept in mind that probably our video course will be aimed at not only at highly advanced kind of super users of Blender, but intermediate users and beginner users. So we wanted to keep it beginner friendly. We wouldn't like to include very complex stuff, like highly sophisticated smoke simulation. Instead we used, again, procedural noise. Aidy stacked a bunch of planes, one on top of the other. And because the noise is 3D noise, it cuts through if you use transparent shader. And then you apply the distance node, which gradually, as you come closer to the plane, it gradually fades this plane. It gradually makes it transparent. And then you fly through it. And it looks damn convincing to me. I think it looks well. Gas clouds, the same thing. Initial tests of flame and smoke simulation looks pretty good, but we ended up using a game development technique, which is called alpha-mapped planes. You just have a bunch of planes with transparent texture. And it works. It works. It is just simple enough. If you allow me a little bit of metaphor, imagine that you play an RPG game, you're level 10 character, you have to kill dragon, but you cannot do it because dragon kills you in one blow. And first you just really want to kill it, but then you have to invent some other ways of dealing with this situation. Like you have to circumvent the situation, sneak past the dragon, or just give it some potion, whatever. You just invent clever ways of dealing with problems. And by the way, with this alpha-mapped planes, you can even do animated stuff if you assign each particle an alpha-mapped plane, and then it looks like this. So you see, simple techniques and pretty elaborate results. This is another example of alpha-mapped glow around the planet. Quasars, the brightest, the biggest objects in the galaxy, probably the single thing that we used, for which we used real volumetric shaders. Like we created this cylinder, and we used a spherical gradient to drive the noise texture, and we plugged it into the volume socket of the volume absorption and volume scatter shader, and it created this accretion disk around imaginary black hole. And on top of that, we added stars, gas clouds, and protuberances as the planes with textures. So we kind of combined two techniques: real volumetric stuff and cheating. And this is my friend Nick. He's standing on the asteroid. Later on, I will show how we did it. Black hole. First attempts to recreate the black hole from Interstellar. By the way, have you guys watched Interstellar movie? Was it good? Yeah. Maybe from the scientific standpoint it sucks. I don't know, but the visualization looked really great, and especially this gargantua black hole effect. And the VFX team of Interstellar have built their own render engine just to render this gravitational lensing effect around black hole. I tried to replicate it using donuts, but really I haven't succeeded. And I suck at physics and at math and AD too. So unfortunately we had to pick another object. We said, well, Interstellar, there was also a wormhole. They thought that it was created by aliens, but in the end it turned out that they created it themselves in the future, some time paradox. So we decided, let's create wormhole instead and call it black hole. And I used a simple glass shader for it. And each transparent shader, each refractive shader has this parameter that is called index of refraction. So water has index of refraction of, I don't remember, 1.3. Glass has this index of refraction. And we really messed this index of refraction using layer weight node. So it goes like from black to white, and near the edges of the sphere, it really becomes crazy. It really bends this index of refraction. It looks like gravitational anomaly. It no longer looks like a glass sphere or something like that. And especially if you animate it, it looks very believable. Very simple technique, very elaborate results. And we started to feel lucky. So at first we stumbled across so many problems with exploding planets and stuff that we couldn't make on time, or just couldn't make at all. And then slowly, gradually, we went through this disillusionment process. We decided not to fight dragons and trolls, stuff like that. And we felt like we are on the right path, because, you know, you just can feel it. And then Blender 2.78 was released. It contained, how do you call it, micro-polygon displacement technique, when the screen gets subdivided, or the geometry gets subdivided, kind of each frame of the animation on the fly, and you can just create very elaborate displacement effects without having to do anything crazy, without having to invent your own level of detail system, stuff like that. Blender does everything for you. So you just use this lunar texture to displace geometry, and that allowed us to take one of our most desired features out of the trash bin, that was planet close-up shot, where you just gradually zoom into the planet's surface. I will show you just like this. And the geometry of the planet gets subdivided on the fly using this adaptive displacement, using the micro-polygon displacement. And I'm messing with the timeline a little bit, because it wasn't included in the original video course. It was an update, just to illustrate my thought. And wormholes, warp drive effects. We saw this tweet by Andrew Kramer from videocopilot.net. I'm a huge fan of him. And we decided to steal this effect, basically. So we recreated this in Blender. And it's just a cylinder with two bones. And we really don't really fly through this tunnel. It just wiggles the tail, and the texture is scrolling. You know, the texture coordinates just scrolling. And I think that's a good metaphor of how we were feeling during the production of this course. We just It was crazy. We didn't know where we would arrive, and we decided to release it in 10 days. Like, stop making it. It keeps expanding. We can go on forever. Let's just release it. And I had a natural deadline because my wife was going to give birth to our kid, and so I just had a window of 1 month to release it, you know, before things happen. And in addition to that, this project, it was like a black hole in the center of the dwarf galaxy. It was consuming the space on our hard drives. It was getting depressing. We decided to release it in 10 days. Actually, it was exactly a year ago. It was on the 30th of November. And I even made this final countdown. We set it to 10 days from this moment. And then we realized that we don't have a teaser, we don't have a trailer, we don't have anything related to promotion. So it was hell of a week, you know. I put together this demo, this demo trailer that I showed to Aidy, and we decided to reuse the stuff that we already had, like some intermediate renders that we made for tutorials, some test renders of various things, and we just took these renders, animated stuff just a little bit to give it at least some motion to it, so we hadn't got time to really create something new for the trailer. We just reused stuff, and and then we decided to make a photo set in spacesuits. That was probably a stupid idea, but when panic monster arrives, when the deadline is looming on you, you do stupid things. No. And not only this, we look like, no, I don't know. And we decided to include rubber duck in every promotional material. At first, it wore pirate hat, but we decided not to play with pirates too much. And you can see, we added it into a trailer, into a teaser. It was hidden in promotional renders everywhere. And here's my friend Nick. He's climbing on the pile of dirt to later on appear in the trailer. I wonder if you would be able to see it, because later on I'll show you the trailer. We released it, we were happy as hell, and then I got email like, "Hey Gleb, just wanted to let you know that your product will soon arrive at CG Peers." And CG Peers is a website with torrents. I use it all the time to download stuff. And so I got this funny email, and we looked and we were shocked. Like on CG Peers you have this page with requests, so you can request some software, and you can upvote and downvote the products. And our Space VFX was at the top of the list. Actually, it got 23 upvotes, more than V-Ray, more than 3D Max, more than 3D Code. It was total insanity, and someone instantly uploaded it to CG Peers. We thought, we are screwed. What can we do? It will ruin the sales, stuff like that. But then we realized that probably no, that's a good sign. That's a sign that people are really interested in getting this course and seeing this stuff. And then Aidy sent me the message on Facebook, one. That meant one sale. We got one sale, yeah. And before I replied, he sent me other